The Tesla Semi Gen 2 is now expected to officially go on sale. Yet since that announcement, Tesla has remained unusually quiet about its electric truck. In fact, it has been a long time since the company released any new footage or meaningful updates about the Semi. The vehicle was first revealed nearly 8 years ago, and its initial delivery event happened almost 3 years back. Even the most recent official video featuring the Semi is already more than a year old. Over time, the project has faced repeated delays, driven by multiple factors. Many observers believe one of the biggest reasons is Elon Musk's strategic shift toward artificial intelligence and full self-driving technology, an area where the Semi plays a critical role. That strategy appears to be progressing well, especially as autonomous trucking is seen as the first major step toward transforming long-haul transport. This focus helps explain why the Tesla Semi is now expected to launch next year instead of by the end of this year, as originally planned. Years ago, Elon Musk surprised the public by suggesting Tesla could eventually produce 50,000 semi-trucks annually, a number many dismissed as more hype than reality. However, during Tesla's recent fourth-quarter earnings call, the company confirmed it already has sufficient 4,680 battery cells and key components to support full-scale production within the next year and a half, while simultaneously pushing semi-development at maximum speed. Perhaps the most intriguing revelation is that the Semi Gen 2 reportedly resolves 3 major design weaknesses that previously drew criticism. Tesla, however, has chosen not to disclose the details. Some followers on X have hinted at possible upgrades, including a longer cabin design and increased payload capacity, fueling speculation throughout the community. This raises an important question. What are the 3 design challenges Tesla quietly solved? And could these improvements enable the Semi Gen 2 to deliver a true breakthrough in electric freight transport? Just as interesting is why Tesla seems intent on keeping everything secret until the final moment. Toward the end of last year, Tesla confirmed the Semi would enter production this year, yet communication since then has been minimal. Skepticism has followed the Semi from the very beginning, with many doubting that a battery-powered truck could realistically travel 500 miles. Still, since its debut in 2017, the Semi has steadily challenged conventional assumptions. The real difficulty has never been battery performance alone, but the infrastructure needed to support it, particularly the construction of massive 750 kilowatt-hours charging stations. At the same time, Tesla's Nevada factory expansion for mass production is still incomplete, and material supply constraints persist. While Tesla likely faces additional internal challenges, one thing is now clear. The Semi is back in position to disrupt the U.S. trucking industry. This is the first Class 8 electric truck powerful enough to realistically replace diesel models. Its operating costs are significantly lower, efficiency is dramatically higher, and has already achieved full self-driving capability, something no other Class 8 manufacturer has matched. Recent job postings further reinforce this momentum. Tesla has listed dozens of semi-related positions across Nevada, California, and Texas, signaling growing activity behind the scenes. Roughly 70 to 80% of the Semi is still assembled by hand due to its complexity, and production remains limited. To date, only around 300 units exist, including those delivered to PepsiCo, with no new customer deliveries announced recently. When the Semi was first introduced, Tesla projected pricing of $150,000 for the 300-mile version and $180,000 for the 500-mile version, with Founder Series models priced at $200,000. Those figures no longer reflect today's realities. Industry estimates now place the 500-mile Semi between $300,000 and $415,000, reflecting major shifts in production costs, battery technology, and economic strategy. Ryder, one of Tesla's customers, recently confirmed these changes forced it to reduce its planned order while still honoring its original financial commitment. Rather than selling the Semi at a loss, Tesla now appears focused on pricing that reflects true production costs and long-term operational value. Recent sightings outside Gigafactory Nevada have offered new clues. Observers spotted several semi-trucks with visible differences, including dark-colored front light shields never seen before. Some believe these changes could indicate the arrival of sleeper cab variants. The refreshed Semi also features a redesigned front end, with headlights inspired by the Model Y and Cybertruck, along with a sleek full-width light bar. The front bumper and roofline have been refined to improve aerodynamics, potentially lowering the drag coefficient from an already impressive 0.36 to around 0.34, a small improvement that could yield significant gains in efficiency and driving range. The windshield has also been reduced and reshaped to enhance airflow, reduce heat intrusion, and improve safety. Tesla has confirmed the refreshed Semi can carry heavier payloads, suggesting weight reductions elsewhere, likely from a redesigned battery pack. Engineers have hinted that future variants may include extended cabins that allow drivers to rest overnight, though this raises questions about weight, range, and pricing. Tesla has also confirmed that the Semi will transition to the 4680 battery format, the company's most advanced cell technology. These high-voltage cells deliver higher energy density, lower costs, and improved efficiency. Despite using a smaller battery pack, aerodynamic gains and improved energy consumption, now estimated at 1.7 kilowatt-hours per mile, allow the Semi to maintain its 500-mile range. Production of these cells at Gigafactory Nevada gives Tesla greater control over its supply chain and manufacturing efficiency. While some critics argue battery availability remains a primary bottleneck, Tesla has begun expanding its Nevada operations, with billions invested into new facilities for semi-production and 4680 cell manufacturing. Once Cybertruck production stabilizes, surplus cells are expected to support the Semi. At present, the limited rollout likely stems from either insufficient mega charger infrastructure or the ongoing vehicle refresh. So the question remains, does the current price of the Tesla Semi justify its long-term energy savings, lower maintenance costs, and operational advantages? With major updates looming and production quietly accelerating, the next chapter of electric trucking may arrive sooner than expected. What makes the Tesla Semi especially compelling is not just its technology, but the timing of its arrival. As fuel prices fluctuate and emissions regulations tighten, fleet operators are actively searching for alternatives that offer stability and long-term savings. The Semi arrives at a moment when the industry is finally ready to accept change. While early adoption may be limited to large corporations with private charging infrastructure, success at this level could accelerate nationwide deployment. If Tesla manages to scale mega charger installations alongside semi-production, the ripple effects could redefine freight logistics across North America. In that scenario, Tesla would not simply be selling electric trucks, but reshaping how goods move, how energy is consumed, and how autonomy becomes embedded into everyday transportation.